All right, so we're going to go back over significant digits. We've been using significant digits all semester, but we're going to review where these different rules apply. People are still, I just got through grading a test, the last major test before the final exam, and people are still making mistakes on significant digits. So first of all, there are significant digits rules that apply to a number that you are given. Okay? So this go ahead, I'm sorry.
So would that be 14?
There are actually 5. Well, there are really 3 things, but if you break addition and subtraction into 2 separate things, then that's 5 things. This is number 14. Okay? A number that you're given. Now this is a measurement or a calculated number. Okay? So let's say you're given a number like this. And if you're just given this number, this is a measurement. Actually, it's a calculated number because you cannot measure moles directly. Okay? You can measure things like mass. You can measure things like volume. You can measure things like temperature, but you can't measure moles. Okay? At least not the kind of moles we deal with in chemistry. So this is actually a calculated number. In this case, these leading zeros are not significant. Okay, now that's a shortcut rule. The actual rule in this case is, actually there are 2 rules, and one of the rules has 2 parts. Okay? So let's just make sure we're clear on this before we move forward. Let's say that these leading zeros are not significant.
So I believe if does that mean like before the 2?
This 0, this 0 right here, this 0 right here, this 0 right here, those 3 zeros are all insignificant. Okay? Then if I have 2,760 grams of carbon dioxide, this 0 right here is insignificant. Okay? Because trailing zeros without a decimal are insignificant. This number, the measurement actually, be written in scientific notation. So we take this 2,760 grams CO2 we move the decimal place 1, 2, 3 places to the left, and we should write the answer then as 2 point third power, because we moved it 3 places. No, we're not doing logarithms at this point. Okay, grams of CO2. All right? Because we moved the decimal place 1, 2, 3 places to the left, we have a positive 3 exponent. Okay? Does that make sense? Now, if we have, on the other hand, 2,760 grams of CO2, okay, all the digits are significant. Or if we have 2,760.0 grams of CO2, all the digits are significant. Now, the actual rules that apply to significant digits in a measurement or calculated number that's given to you are, this is a 1-part rule. Okay, the 1-part rule says zeros between 2 significant digits are significant. The 2-part rule zeros that follow both a decimal and a non-zero digit are significant. All non-zero digits in measured or calculated numbers are significant. Now, all that goes toward explaining number 14 on that practice final exam. Okay? The actual rules are these right here. But the application of it, I've given you the explanation. Remember, you need to do more than simply be able to write an answer on the practice test. The practice test is to help you get ready to solve problems on the final exam. So if all you do is answer it, but you don't understand, what are you going to do on the final exam? Fail. Okay? So I want you to be able to do the final exam, make an A. So you not only have to write, that's why I tried to spread out all these questions for you, not so you can just have an easy time, but so you can take the time to understand. Got it? If all you do is copy down answers, that's not helping you very much. All right, now that's just significant digits for numbers that are given to you. Okay? Has everybody got these notes?
Wait, so 14, okay, so there were the ones for numbers that are given to you.
Mm-hmm. Which is what, 14?
Okay.
All right?
What's the numbers that, given?
So now let's cover addition and subtraction. Okay? So in order to make this,
so are you just going to put 15 and 16 together?
yes, as simple as possible, I've given you these rules. Determining the significant digits let's see, in an addition or subtraction problem. Carefully line up all digits in a vertical fashion. Just like you were taught in elementary school. Do not put extra zeros on any number. You can use arrows as placekeepers. Do the addition or subtraction. Underline any digits that have empty slots. Above them, or any digits that have arrows as placekeepers. Above or below them. No, just above them, because we don't want, because this is the final answer we're talking about, above them. Round off those underlined digits. Use an arrow to show that you are rounding. Do not use an equal sign. Okay, so here's the example I want to give you. And this is for addition or subtraction. I'm just going to do a simple subtraction problem, okay? I'm going to take 100.00 milliliters of hydrochloric acid solution. I'm going to subtract 25.3 milliliters of hydrochloric acid solution. So you can notice here, or you should notice here, that you've got an empty slot under that 0 right there. Now when we subtract, we get a 0 here, a 7 here, a 4 here, and a 7 here. Units of measurement, milliliters, hydrochloric acid solution. Notice I've kept my units of measurement and my species on every single measurement or calculated number, because I want to make sure I'm clear about identifying what those numbers apply to. That's an aside to the question of significant digits. To the question of significant digits, all we have to do is to find those numbers that result from empty slots or arrows. And that would be only, in this case, that one digit right there. Now, if you do this in your calculator, you're not going to get that 0 right there. You have to be smarter than your calculator. Your calculator will give you 74.7, and I'll allow you to use calculators in here. That's perfectly okay. But you have to be smarter than your calculator. You have to know if I need to add an extra digit or if I have to remove a digit. And zeros are problematic with calculators. Okay? Especially zeros on the right. And then we're going to use an arrow to show that we're rounding off. Okay? We're going to round off that 0. In this case, we're going to get 74.7 milliliters of HCl solution. Now, this number is equal to that number, but a lot of times I'm rounding off a 3 or a 7 here, in which case this number would not be equal to that. That's why we use an arrow and not an equal sign, because this does not usually mean equal to that. You want to communicate what's really going on, okay? Not just some operator you just throw in there. Communicate what you're actually doing. Be clear. Okay? Everybody clear about that? All right. Let's go to multiplication and division then. Now in chemistry, most of the time, when we're doing multiplication and division, we're doing a bunch of fractions that we're multiplying together, but fractions themselves are division problems. Okay? Now I'm going to stick with something very, very simple for my example, but I'm first going to give you the rule, then I'm going to show you an example. Okay? So the first thing you want to do is identify all the measured or calculated numbers in the problem. This is another reason why units of measurement and species are so important when you're writing out problems with real world stuff like in chemistry. Okay? Because it's really hard to tell what your measured or calculated numbers are without those. Okay? And these numbers are the only ones we'll use, only ones that you will use to determine the significant digits in your answer. Okay? And so you're going to find the measured or calculated number with the least total of digits and round your final answer to that number of digits. So what I want to do now is to convert 2.374 grams of water into moles. This is my example problem. Okay? Now to do this, we've got to know the molar mass of water. If you're converting from grams to moles, or if you're converting from moles to grams, you must know the molar mass. Molar mass is that magic equality statement that allows you to convert between grams and moles, or moles and grams. Okay? Water is H2O, so to do the molar mass, to find the molar mass, we need to have 2 hydrogens and 1 oxygen. Hydrogen's atomic mass is 1.00794 on your periodic table, and oxygen is 15.9994. We have 2 hydrogens and we have 1 oxygen, so we know we're going to have 15.9994 for the mass of the oxygen here. And we're going to have 2.01588. Now, I've lined all my digits up vertically really, really neatly because this problem here is addition. We're going to use the answer from this problem to do multiplication and division. Okay, now you notice that we have a empty slot right here under this 8. So we're adding these numbers together. We've got 18.01528. Using the same rules we just learned about addition and subtraction, we're going to underline the digit with the empty slot or the arrow placekeeper. We're going to draw an arrow to show that we're rounding off. We can't use an equal sign. And we write the rounded off answer, 18.0153. Now, in this case, this number and this number definitely are not equal. And so we can't use an equal sign there. Okay? But we have to identify what this is. You have to know, when you are calculating molar mass, that this is grams of the species, H2O, in this particular case. And for my class, you're always going to write an equality statement to be able to use it for conversions. You know, those of you who have earplugs in, don't you think this would be a really good time to take them out? You know, I mean, that's got to be distracting. If you're listening to something else while I'm teaching you, there's no way you can give me 100% attention. Is there music going into your ear? You really should remove it so I don't have to worry about it, okay? I'm worried about your learning this stuff, okay? All right, now, you must write for me that there's an equality statement here, and you must always know that when you calculate the molar mass, that is equal to 1 mole of that species. In this case, the species is H2O. Now we're going to take our starting amount, 2.374 grams of water, and we're going to put it over the top of a fraction with a 1 underneath. It doesn't change the amount. All we're doing here is putting it over 1 as a kind of placekeeper to make the math work out neatly for us. And then we're going to build a conversion unit from the equality statement. Now listen, all conversion units must have an equality statement. Okay, now a lot of times you know what they are just because you have it in your memory. I make you write it down in here to emphasize that. Okay, every time you have a conversion unit, you need an equality statement. Okay? This is an equality statement. It's two things that are equal to each other, with the units, in some cases, the species as well. In this case, you do have the species. What I want to do now is to choose the side of the equality statement that matches the units and species of my starting amount. Well, this side of the equality statement has the same units, grams, and the same species, H2O, as the starting amount. Now I'm going to put that number, unit, and species on the bottom of the next fraction. And the reason I did that is because it's going to allow me to cancel out grams and the species water and leave myself with just what I'm looking for. The problem is saying we're looking for moles. And I'm going to put the other side of the equality statement on the top. Now the neat thing is this fraction right here equals 1. When you multiply by 1, you get the same thing you started with. We're going to change the units of measurement without changing the actual amount. And that's what a conversion unit does. It allows you to change the unit of measurement without changing the actual amount. What we're going to do is we're going to cancel grams and H2O in exactly the same way that you cancel X's and Y's in algebra. We're going to find an answer now. So we're going to take this number, which is on the top of this fraction, and divide by this number, which is on the bottom of this fraction. And I get 0.1317768785. And this is the number of moles of H2O I get from this calculation. Now your calculator may give you a few less numbers. That's perfectly okay. You write down all the digits you get from your calculator. And then we're going to round it off. Now here's where you apply the rule. This is multiplication here and division. This is a multiplication and division problem all wrapped up in one. Okay? So we're going to look at the numbers that we have. that are measured or calculated. The measured numbers that we have in here is just this one right here. The calculated number we have in here is this one right here. We calculated it right there, so we know it's calculated. So all those two numbers, we're going to choose the one with the least number of digits, okay? This one has 1, 2, 3, 4, 5, 6, and this one has 1, 2, 3, 4. So this is our measured or calculated number with the least total digits, okay? These numbers right here are not measured or calculated, so we're going to ignore those. All we care about are the measured or calculated numbers. So since that's our least number of digits is 4, we're going to underline everything but the first 4 digits. Now remember the rule about numbers that are given to you. Leading zeros are not significant. So the first significant digit is this one. 1, 2, 3, 4. Underline everything else. Draw an arrow to show that you're rounding off. We're going to round it off to that 4 significant digits. 0.1318. This 7 makes this 7 round up to an 8. Anything 5 and above makes the number next to it round up if that's where you're rounding from. Moles H2O. I'm putting a box around it to show that's my final answer. Now, there's one more category of significant digits that we in this class kind of ignore. That's logarithms and exponents, because you can convert back and forth between those, as you know from our look at acids and bases and pH and that sort of thing. Now look, all we do is apply the multiplication division rules to our exponent logarithm math, okay? Does that make sense? So we're kind of simplifying that a bit. You got it? All right. So you only got a few more minutes. Make sure you have those last few questions. You've got to finish through number 20 today in class. All right? And tonight your homework is, what is it, 21 through 40, is it? Okay. 45? You're supposed to finish through number 20 in class.
1 through 20.